Hello friends, welcome to my channel Chemical Homes. Today I will teach you a very important and interesting chapter in chemistry which is redox. Redox is nothing but oxidation and reduction. Oxidation is loss of electron and reduction is gain of electron. An example of oxidation is sodium minus electron to give sodium plus, and example of reduction is chlorine plus electron to give Cl minus. Now what is oxidation number? In short we can say it as On. It is the degree of oxidation of any atom in a compound. There are few rules to calculate oxidation number of atoms. These rules are: first, oxidation number of free elements equals to 0. For example, hydrogen, nitrogen, sodium, in all the cases oxidation number is 0. Rule 2 is oxidation number of hydrogen in any compound is equals to plus 1. But there is an exception, which is metal hydride. For example, sodium hydride. Here oxidation number of hydrogen is minus 1. Now rule 3 is oxidation number of oxygen in any compound is usually minus 2, and exceptions are peroxide compounds like H2O2. Oxidation number of oxygen is here minus 1. For OF2 it is plus 2. For O2F2 it is plus 1. And a very interesting is superoxides, for which oxidation number of oxygen is minus half. Now come to rule 4. Oxidation number of any metal, say M, it is equals to its valency, and it is always positive. But here is also an exception. Germanium hydride. Oxidation number of germanium is minus 4 here. Rule 5 is oxidation number of atom M or metal M in metal carbonyls is equals to 0. For example, nickel, CO whole 4. Here the oxidation number of nickel is 0. Rule 6 is very important one. Sum of the oxidation numbers of all the atoms in a compound is equal to 0 if it is a neutral compound. Rule 7 is also very important. Sum total of oxidation number of all the atoms in a charged species mandate it is charged species and here it is neutral. For charged species it is equals to its charge. Just keep in mind these 7 rules and then you can solve any problems from oxidation number calculations. Let us see few examples so that the rules will be clear to you. First example is nitric acid. And we have to calculate the oxidation number of this nitrogen. Let us consider is as unknown and it is X. We have to calculate X and for hydrogen, one hydrogen we have plus 1. For 3 oxygen we have 3 into minus 2. This comes out to be 0 because it is a neutral. So we can easily find X as plus 5. The second example is NH4NO3. This exists as NH4 plus and NO3 minus. We have to calculate the oxidation number of all these two nitrogens. For NH4 plus, we have oxidation number of nitrogen is X and for 4 hydrogens 4 into plus 1 and it is a charged species so it is equals to plus 1 which is its charge. Then X comes out minus 3. Again for NO3 minus let oxidation number of nitrogen is X and for 3 oxygens we have 3 into minus 2 and this equals to its charge which is minus 1 and then X becomes plus 5. These two nitrogens in NH4NO3 have two different oxidation numbers which are minus 3 and plus 5 respectively. Now come to a very interesting example, chromium O5. This is known as parchromic acid. It has a very interesting structure. 4 oxygens remain as these and The last one is as this position. Very similar to a butterfly structure. So it is known as butterfly structure. Okay. We have to calculate the oxidation number of this chromium atom. Let us consider it as X as previously, and then for 4 oxygens. These four oxygens are bounded by peroxo bonds. So for these we have oxygen oxidation number as -1, which is in rule 3 or rule 3. So for 4 oxygens, oxidation number of oxygen is -1, and the remaining fifth oxygen, which is a normal oxygen, the oxidation number is -2, and this is equals to 0 because it is a neutral species. So the X value becomes +6. So oxidation number of chromium McrO5 is +6. These are all for today. Hopefully you can understand and learn how to calculate the oxidation number of any atoms in a compound. If you like this video, please like, share and subscribe. In my next video, I will teach something more about redox reactions. Thank you.